Hi everybody, in this video let's look at how do we describe a combined transformation and how do we solve some problem involving combined transformation. Let's look at the first question. The diagram shows quadrilateral ABCD, PQRS and PEFG drawn on a Cartesian plane. So here we have three quadrilateral ABCD, PQRS and PEFG. Let's look at part A. The transformation T is a translation 6, -1. When you see 6, -1, you know that you need to move your object 6 units to your right and 1 unit go down. This number tell you move to your right or move to your left. If this is negative, it means that move to your left. If this is positive, move to your right. The number underneath here tell you move up or move down. Positive, move up, negative, move down. Okay, so the second transformation is R, which is a refraction in the line y equal to 1. This is the axis of refraction. Find the coordinate of the image of the point B under each of the following transformation. Point B is over here. Okay, A1. The coordinate of point B is -2, 4. What are the coordinates of the image of point B under the translation T? So I will encourage you to write this here also, so easier for you to get the coordinate of the image. So you can write beside the T as well, both are okay. You don't have to calculate using your diagram. You can just use the number here to help you to get the answer. -2 plus 6. If you don't see any sign here, it means plus. -2 plus 6, you will get 4. 4 minus 1, you will get 3. So this is the answer. If you don't want to do it this way, you can calculate using your diagram. But you need to be more careful because a small grid given here, representing only 0.5 units. So when you want to calculate 6 units, you need to be more careful. 1, this is 1, okay? 1 unit, 2, 3, 4, 5, 6. Okay, 6 units to your right and 1 unit go down, 1. Okay, so this is B prime, which is 4, 3. Both will give you the same answer. Let's go to part 2. This is a combined transformation RT. You need to be more careful. RT, T is the first transformation and R is the second transformation. So the first transformation is T. So this one we have done it just now, so we don't have to do it anymore. We just copy the answer. Okay. Now we are going to transform it using the transformation R. Second transformation. Since this is a second image, I will write B double prime. This is a refraction, so we need to draw the axis of refraction first. Y equal to 1, which is over here. Y equal to 1. You need to be more careful when you want to determine the coordinate for B double prime. You cannot start from here, but start from here, because from P already moved to B prime. So now we have to start from here. 1, 2, 3, 4. Okay, start from 1 again. 1, 2, 3, 4. Okay. So the final answer, B, the coordinate for B double prime is 4, -1. 4, -1. Okay, so this is the answer for part 2. Now let's go to part B. PEFG is the image of ABCD under a combined transformation WV. PEFG. The biggest quadrilateral is actually the image of this ABCD under the combined transformation WV. Describe in full the transformation V and W. Okay, the combined transformation involved here is WV. It means that the V is the first transformation and W is the second transformation. When you look at the diagram here, you know that the two transformation involved is actually rotation and enlargement, right? The question is actually trying to help you by drawing you this PQRS. It wants to give you a hint that from A, B, C, D, move to PQRS, transform to PQRS first, then enlarge become P, E, F, G. Okay, so from A, B, C, D to PQRS is actually a rotation, right? To describe a rotation, you need to mention three things: direction, clockwise or anti-clockwise means, and the angle of rotation, and also the center of rotation. Okay, so first, let's determine the center of rotation. To determine the center of rotation, you can use your compasses to help you to get the centers. Okay, so we need two pair of corresponding vertices. So let me use A and P first. What we need to do is just construct a perpendicular bisector of AP. So we know that the perpendicular bisector of AP is somewhere around here. So when you make the arc, you don't have to make it here or here. Just make an arc somewhere around here. Somewhere around here. Okay, do the same thing at the bottom here. Now move your compasses and place the needles of the compasses on P. Keep the same width. Don't adjust the width. Okay, so next step is just connect these two intersection points together. One pair of corresponding vertices is not enough. So now we only have one perpendicular bisector. We need to use another pair of corresponding vertices to help us to get another perpendicular bisector. Okay, so this time let me use C and R. So you cannot use B and R because they are not corresponding vertices. If you don't want to use C and R, you can use D and S or B and Q. Okay, let me use C and R. Okay, it's a little bit hard for me to draw it here. How about I change it to B and Q. So B and Q, the perpendicular bisector is somewhere around here. So just make an arc over here. Keep the same width, do the same thing at the bottom. Then move it to Q. Using the same width, make another arc here and here also. Okay, sometimes you cannot get the intersection point. Don't worry, you just move back to here. Draw it again. Okay, let me try to draw it more accurate. Okay, now we got the intersection point. Next step, just connect this and this together. Okay, now you will see these two perpendicular bisectors intersect here. So the intersection point between these two perpendicular bisectors is the center of rotation here. This is a center of rotation. Now we have golden the center of rotation, we need to know what is the angle of rotation. Just by looking at it, you can actually figure out, right? That is 90 degree. So if you want to draw it, you can draw it this way, 90 degree clockwise. Okay, now we can start to describe this rotation. The combined transformation is WV. Okay, let me use another color. Okay, so V is the first transformation, which is a rotation. V is a clockwise rotation of 90 degree about the point or about the center, both are okay. 0, 1. So just remember, to describe a rotation, we need to mention three things: directions, angle of rotation, and also center of rotation. If the rotation involved is 180 degree, then you don't have to mention the direction, is okay. Because if the rotation is 180 degree, no matter you rotate it clockwise or anti-clockwise, both will give you the same thing. Okay, now let's go to W. We know that W is actually an enlargement. To describe an enlargement, we need to mention two things: the scale factor and also center of enlargement. Just by looking at it, you can actually know the center of enlargement is over here, right? But you need to be more careful. To determine the center of enlargement, sometimes we need to add a negative for it. Okay, let's look at this one. This is object, this is the image under an enlargement with the scale factors 2. So how do we get the scale factors? Remember, when you want to calculate the scale factors, first thing, observe the positions of the center of enlargement. If the center of enlargement is one side and image object another side, in this situation, the scale factor will be positive. Sometimes you will notice that image another side, sometimes you will notice that the center of enlargement is actually located between object and image. In this situation, the scale factors will be negative. You need to add a negative for the scale factor. Okay, so how do we get the center of enlargement? It's actually pretty simple. We just need two pair of corresponding vertices. So for example, now I just connect A prime and A. Then B prime and B, or C prime and C. The intersection point between these two lines is the center of rotation. Sorry, not center of rotation, center of enlargement. Okay, so how about when we have a negative scale factors? Do the same thing. Now we have a negative scale factors because the center of enlargement is actually located between image and object. To determine the center of enlargement, still the same thing. We just need two pair of corresponding vertices. Okay, let me use B prime and B, A prime, A and A prime. Okay, the intersection point between these two lines is the center of enlargement. To determine the scale factors, remember, we need to put image, the length of the side of image, on the top, then divided by the length of the corresponding side of the object. This is at the bottom. So here with 2 units, 1 unit, 2 divided by 1, you will get 2. But we need to add a negative because the center of enlargement is actually located between the object and image. So let's say for this situation, how do we get the scale factors? We take 3 divided by 1. So you will get 3. And we don't have to add a negative sign because image, object one side, center another side. So how about when we have like this? Okay, same thing, but this time this is 0.5 unit, this is 1 unit. You take 0.5. Always remember, put the length of the side of the image on the top. 0.5 divided by 1, you get 0.5. Positive because image, object one side, center another side. How about this situation? This time it will be negative because center of enlargement is actually located between image and object. Okay, let's go back to the question just now we discussed one. Okay, so in this situation, you actually don't have to draw two lines to help you to get the center of enlargement. You just look at it, you know. But if you want to draw it, you can draw it this way. Let me use blue color. Choose two pair of corresponding vertices, E, Q, O, F, R, or G, S. Any two pair. So how about let me use EQ and GP. You will notice that this is an intersection point between these two lines, these two lines, right? So this is the center of enlargement. To determine the scale factor, which is K, remember image on the top, object at the bottom. Okay, so how about we use F, P, compare with R, P. So here you can calculate how many small grid or how many units. If you want to calculate how many small grid, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 small grid. How about this? 1, 2, 3, 4, 5, 6. You will get 2. If you don't want to calculate this way, you want to calculate how many units. So it will be 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. Then divided by 1 unit, 2 unit, 3 unit. You will still get the same answer, which is equal to 2. Okay, now we have the center of enlargement and also scale factors. Now we can start to describe this enlargement. W is an enlargement at the center. The center here is 2, 2 with a scale factor of 2. Okay, so the scale factor we don't have to add a negative here because we notice that center of enlargement one side and object image another side. So in this situation, we don't have to add a negative sign for the scale factor. Okay, let's try the last one, P2. Given that the area of the shade region over here, which is the area is 54 square centimeter, calculate the area of PQRS. Where's PQRS? So we want to find the area of PQRS, which is over here. So first you need to think, how do we get the area of the shape region? We take the area of the whole image, right, minus the area of this object PQRS, right? So we need to write an equation. You need to remember this formula. Area of image is equal to K square. This is the formula for finding the area of image under an enlargement. Is equal to K square times area of object. Now we don't know the area of object, so from PQRS enlarge become PEFG, right? So we just let the area of object be A. So the K, the scale factor, which is 2, right? So 2 square times A. So the A is representing the area of object, which is PQRS. So this is 4A. How do we get the area of the shaped region? We take the area of the image, 4A, minus the area of the object, PQRS, right? Which is A. And this is equal to area of the shaped region, which is 54. So 3A is equal to 54. A is equal to 54 divided by 3. A is equal to 18 square centimeter. Okay, so area of PQRS is equal to 18 square centimeters. So remember this formula, we always need to use it to help us to get the area of the image or the area of the object under an enlargement. Okay, let's try one more question. The transformation T is a translation. Okay, this one should be no problem, right? -2, 3, you know that 2 unit to your left, 3 unit go up. And the transformation M is an anti-clockwise rotation of 90 degrees about the point 2, 0. So always remember, when you want to describe a rotation, you need to mention 3 things: direction, angle, and the center. But if the rotation involved is 180 degrees, you don't have to mention the direction, is okay, because if the rotation involved is 180 degrees, no matter it goes clockwise or anti-clockwise, both will give you the same image. Okay, we want to state the coordinates of the image of point 6, -2. Under the following transformation. Okay, as I told you just now, for translation, right? You don't have to calculate using the diagram, but here we don't have a diagram also. But if you want to calculate from the diagram, you can use the diagram here to help you. Okay, the translation is -2, 3. So you can write here also -2, 3. Easier for you to get the coordinate of the image. Let me write bigger. 6, -2. After this translation, T, which is -2, 3. 6 minus 2, it will become 4. -2 plus 3, it will become 1. So this is the answer for 1. How about this one? Okay, this t square, you need to be more careful. Some students take this one to square it, which is not correct. You can't do it this way. So the t square just means that 2 times of this. First time. Okay, which is this one, 4, 1. One more time again. Same translation. 4 minus 2, you will get 2. 1 plus 3, you will get 4. Okay, so this is the answer for part 2. How about part 3? So this is a rotation. It will be more difficult for us to determine the image. So we don't have a diagram, it's okay. We can borrow the diagram from part B to help us to get the answer. 6, -2 is which is over here. 6, -2, which is over here. 6, -2. Undergo a transformation M, which is a rotation, anti-clockwise rotation of 90 degrees about the point 2, 0. So 2, 0 is over here. This is the center of rotation. anti-clockwise, go this way, 90 degrees. So start counting from here. So same thing, this is one small grid representing 0.5 units. So you can calculate 1, 2, 3, 4, 5, 6 like this. If the one you want to calculate how many units, you can calculate this way. 1, 2, 3, 4, right? 1, 2, 4 units, 2 units, 4 units, 2 units. When you rotate it anti-clockwise 90 degrees, go this way, it becomes 4 units, 2 units, right? Okay, so 1, 2, 3, 4. 1, 2. Okay, the final answer is over here, 4, 4. Let me write here. 6, negative 2 undergo this transformation M, which is a rotation. So the image will be 4, 4. Okay, so this is a way how we determine the image of a rotation. If you don't want to calculate this way, you want to calculate this way, no problem, you still get the same answer. So you can calculate this way, for example, 1, 2, 3, 4, 5, 6, 7, 8. Okay, then 1, 2, 3, 4. It becomes 8, 4. Here do the same thing, 8, 4. You get exactly the same answer. Okay, now let's move on to part B. PQRS is the image of ABCD. Okay, where's PQRS? PQRS is the image of ABCD under the combined transformation VW. Describe in full the transformation V and W. So you notice that this question is actually trying to help you. It provides you this E, F, G, H. It's actually want to tell you that from A, B, C, D transform to E, F, G, H first, and then enlarge become P, Q, R, S. Okay? So the combined transformation is VW. Be careful, this is the first one. This is the second one. Okay, let me describe the first one first. V and okay, W is the first one. From here, go here, we know that this is actually an this is a refraction. To determine the axis of refraction for this one, you actually just by looking at it, you know. But if you want to use a compasses to help you, you can do it this way. Just choose one pair of corresponding vertices. So you can use C and G, or D and H, or A, E, and so on. All will give you the same answer. Okay, let me use C and G. But this one actually you don't have to use the compasses, just by looking at it you know the answer actually. We want to construct the perpendicular bisector of CG. Then keep the same width, don't adjust it. Place over here. Okay, do the same thing. Just connect them together. Okay, how do we name this line? What is the equation of this line? This is x equal to -1, right? So now we already got the axis of refraction. We can start to describe it. W is a refraction in the line x equal to -1. X equal to -1. Let me draw it here also. X equal to -1. This line. This is an axis of refraction, x equal to -1. So this one you can use in the line or on the line, both are fine, as long as you need to mention the axis of refraction. Okay, now let's go to the second transformation. Normally, one of the transformation for this combined transformation will be, one of them will be enlargement normally, because the questions were asked to calculate the area of the image or the area of the object under an enlargement. Okay, so remember, to describe an enlargement, you need to mention the center of enlargement and also the scale factors. Let's determine the scale factors first. The scale factors, you can use this side, RS divided by GH, because these two are corresponding side. Okay, RS how many units? 1, 2. Okay, this is not 2 units, this is 2 small grid. But you want to calculate how many small grid or how many units, both are fine, will give you same answer. Normally the question will give you one small grid is 1 unit, but given diagram here, one small grid only representing 0.5 unit. Okay, let me calculate how many units. 1 unit, 2 units, 3 units, 4, 5, 6 units. Remember, image on the top. So 6 on the top. Object at the bottom. 1, 2, 2 units. So eventually we will get 6 divided by 2, you will get 3. Okay, so the scale factor is 3. Not -3 because we know that the center is somewhere around here, right? And this is the image, this is object, this is image on the same side. So the scale factor will be positive. We don't have to add negative. So where the center of enlargement? Just by looking at it, you know. If you don't know, you can actually draw 2 lines to help you to get the answer. Just choose 2 corresponding vertices, S and H, P, E, Q, F, or RG, any 2. Okay, let me use S and H, 1 pair. Okay, so you cannot use RG actually, because RG and SH create the same line. We need to use another pair. How about PE? Okay, now this is the intersection point, right? So this is the center of enlargement. Center of enlargement. Okay, now we can start to describe it. The coordinate is, this is 1, 2. 1, 2. V is an enlargement at the center, 1, 2, with a scale factor 3. Okay, so we have mentioned the center and the scale factors. This is the way how we describe an enlargement. Okay, now let's try the last part. Given that the area of ABCD, where's ABCD? This one. 15 square centimeter. We want to calculate the area in square centimeter of the shaded region here. Okay, if this is 15 square centimeter, we know that here must be 15 square centimeter first. Must be 15 square centimeters also, right? So if we want to get the area of the shaded region, we need to find the area of this entire image first, then we minus this 15, so that we can get the area of the shaded region. How do we get the area of the image under enlargement? So remember this formula. Area of image is equal to k squared times area of object. Okay, let me erase this one right over here. Area of image we don't know, we want to find, I just let it be A. K, okay, the scale factor is 3, so 3 square times area object, which is equal to 15. Nine times 15, 9 times 15就是15。Okay, 135 square centimeters, but this is not the final answer yet because the question is asking the area of the shaded region. So what we need to do is area of the shaded region is equal to 135 minus 15. Okay, which will give you 120. This is the final answer. Okay, that's all for this video. Thanks for watching. See you next time. Bye bye.